Finding the ascending powers of x up to and including the term x cubed, the series expansion of 1 plus 3x to the minus 1. State the values of x for which the expansion is valid. Well, first of all, we're going to use this formula for the binomial expansion that we've already looked at in the last video. So we've got 1 plus 3x to the minus 1. So the x in here, this x here, becomes 3x. So everywhere there's an x in this formula, we are going to put 3x. And obviously everywhere there's a n in this formula, we're going to put minus 1. Okay, so let's start off with that. So let's expand that. So we've got 1 plus n, which is minus 1, times by x, which is 3x, plus n, which is minus 1, times n minus 1, which is minus 2, n minus 1 minus 1 is minus 2, over 2 factorial, times by x squared. Well, we've got 3x all squared. Common mistake is not to square the 3. Plus, same again, n is minus 1, n minus 1 is minus 2, n minus 2 is minus 3, divide by 3 factorial, and we've got 3x all cubed. And that's as far as we need to go, up to the term x cubed. So we get 1 minus 3x, minus 1 times minus 2 is 2, 2 factorial is 2, so this is just going to cancel out to be 1. 3 squared is 9, so we get 9x squared. Now we got minus 1 times minus 2 times minus 3, that's going to give us minus 6 over 3 factorial, which is 6. So that will give us a minus sign. 3 cubed is 27, x to the power of 3. And that's our expansion. Now it states the value of x for which the expansion is valid even. Now in here, okay, remember we knew that x had to be between minus 1 and 1, but we've got 3x. So 3x is has to be between minus 1 and 1 for this expansion to work. So therefore this implies that the values of x for which this is valid is between minus 1/3 and 1/3. So divide this by 3 to get x. So therefore we must divide this by 3 to get minus 1/3, divide this by 3 to get 1/3. And that gives us the values of x for which the expansion is valid.